Hello, ladies and gentlemen, and welcome back to Distance Learning Algebra 1 with Mr. Hagedorn. Today we jump into Unit 8, and we are going to, in Unit 8, start talking about solving quadratic equations. The first way that we're going to do is exactly what we finished up with in Unit 7, and that's solving quadratics by factoring. Now, in order for us to do this, we have to understand the property of zero, specifically the zero product property. Here I have some examples. It says if b equals 0, then obviously b equals 0. If a times 5 equals 0, then a equals 0. And then if a times b equals 0, then a equals 0 or b equals 0. In the first two statements, notice it had to be a and it had to be b because the other ones are constants that we know aren't 0 themselves, and anything times 0 is 0. So we're going to use the zero product property, but we're not going to use it from the standpoint of just one variable times one variable. We're going to use it from the standpoint of one binomial times another binomial. But the zero product property for us will be if a times b equals 0, then either a equals 0 or b equals 0. So to do that, what we are going to do down here in the problems that you see is we are going to simply set them equal to 0. Each binomial factor will be solved separately and be part of our solution. So for the first example, we'd set it up by saying x minus 5 is equal to 0 or x plus 4 is equal to 0. So if those statements are true, here we'd add 5 to both sides, and it tells us that x equals 5, or in our second one, we would subtract 4 from both sides, and we'd get x equals negative 4. The reason for the or is we can use either one of those in our original problem, and it would make the statement true. So the or statement here means we're putting them in individually, not at the same time. The next example that we have is just a little bit more involved, nothing any more difficult. We'd set our factors equal to 0 once again. So we have 2x minus 3 equals 0, or 3x plus 4 equals 0. And as you can see, the key already to this is our factors, our polynomials, everything have to be equal to 0 in order for this to work. So in our first example here, we'd start by adding 3 to both sides, which would give us 2x is equal to 3. Then we divide both sides by 2, and we get x is equal to 1.5. Or, in the second one, we'd subtract 4 from both sides, which would give us 3x is equal to negative 4. We divide both sides by 3, and we would get negative 1 1/3. So again, like we did in our first example, we have two solutions that can be used separate of one another, but both of them make our original equation true. Now we have a couple of examples here that are going to involve factoring. The first one is the most basic of all the factorings that we have, and it's the greatest common factor. So if we do that and factor it out, we'd have the greatest common factor is 5x. So we factor that out front, just like we talked about in Unit 7. What that would leave us with is x minus 1, and now that's equal to 0. Once you've factored it completely, you set your factors equal to 0 and solve. So in this case, we'd get 5x is equal to 0, or x minus 1 is equal to 0. In the first one, we would divide by 5 on both sides, so we would get one of our answers is x is equal to 0. Or, in the second one, we add 1 to both sides, and we would get x could also be equal to 1. So there's an example of greatest common factor factoring in order for us to work. Now the second example brings into play one of the biggest hurdles that we have to overcome, and that is to remember that our polynomial must be equal to 0. So in this case, in order to do that, I would simply add 12x squared to both sides. Now since they're not like terms, we can't combine them, and it would leave us with 0 is equal to 12x squared minus 30x. Once again, this brings into play greatest common factor factoring, and in this case the greatest common factor that we could factor out of those would be 6x. So that would leave us with 0 is equal to 6x times the quantity 2x minus 5. Now that we factored it completely, we set our factors equal to 0 once again. So we'd have 6x equals 0 or 2x minus 5 equals 0. And for the first one here, again, we simply divide both sides by 6, which would leave us with x is equal to 0. Or in our second one, we'd add 5 to both sides, which would give us 2x is equal to 5. Then we divide both sides by 2, and we end up with x also equaling 2.5. So again, here, remember, ladies and gentlemen, greatest common factoring is one of the factoring methods we can use, and our quadratics must always be equal to 0 in order for this to work. So in these expressions, notice that now we're actually dealing with some of the upper level quadratics that we dealt with in chapter 7. So in the first example that we have here, what we're going to need to do is we're going to need to get it equal to 0, and the easiest way for us to do that is to simply subtract 18 from both sides. So that would leave us with x squared plus 3x minus 18 is equal to 0. So for this one, what factors of negative 18 when added together equal 3? The answer is positive 6 and negative 3. So once we've factored it, ladies and gentlemen, our next step would simply be to set those factors equal to 0 and solve. So we have x plus 6 equals 0 or x minus 3 equals 0. In the first one, we'd subtract 6 from both sides, which would leave us with x equals negative 6. Or in the second one, we'd simply add 3, which would leave us with x equals 3. If we check those in our original, negative 6 squared is 36. 3 times negative 6 is negative 18. 36 minus 18 is 18. If we put in 3, 3 squared is 9. 3 times 3 is 9. And 9 plus 9 is 18. I won't check every one of these, but I will tell you that as part of this, the biggest thing that you can do to help yourself is to check your work. Okay? All right, the next one, we have to solve using the British method. So we multiply the two outside together, and that gives us negative 70x squared. And now we ask ourselves the question, what factors of negative 70x squared when added together give us negative 3? And the answer is negative 10x and positive 7x. We bring down the outside two terms, which gives us 2x squared minus 10x plus 7 minus 35. We're not going to forget about the 0, but we're not going to worry about it right now until we've completely factored this. So remember now, if we group the first two together, we factor out the greatest common factor of 2x, which leaves us with x minus 5. And in the second group, we factor out the greatest common factor, which is a positive 7, and it also leaves us with x minus 5. So remember now, because those binomials are the same, they become our first factor of x minus 5, and the greatest common factors that we factored out in grouping become our second factor, which is 2x plus 7. Here, ladies and gentlemen, is where we bring back in the 0, because now we need to set our factors equal to 0. So we have x minus 5 equals 0 or 2x plus 7 equals 0. Here we would simply add 5 to both sides, and that would give us one of our solutions, x equals 5. Or subtract 7 from both sides, which gives us 2x equals negative 7. We divide both sides by 2, and that would give us our second answer of x equals negative 3.5. And as far as the form of your answer, ladies and gentlemen, I do not mind if you'd have negative 7/2, negative 3.5, or negative 3.5, as long as your answers are exact. The last example that we have here, ladies and gentlemen, on this page is one where we are actually going to have to distribute first, then we're going to have to get it equal to 0, and then solve it algebraically. So for this example, ladies and gentlemen, if we distribute, that would give us 3x squared plus 14x is equal to 5. So now we set it equal to 0 by subtracting 5 from both sides. And that leaves us with 3x squared plus 14x minus 5 is equal to 0. Once again, we use the British method, which gives us negative 15x squared. And the factors of negative 15x squared that give us 14x as a sum would be 15x, positive 15x, and negative 1x. We bring down the outside terms, leaves us with 3x squared plus 15x minus 1x minus 5. If we group those, the first group has the greatest common factor of 3x, which leaves us with x plus 5 in parentheses. And for the second group, remember if the leading term is negative, we factor that out. So in this case, it would actually be negative 1, which would leave us with x plus 5. So now the factored form of that would be x plus 5 times 3x minus 1 is equal to 0. Once we are at this point, ladies and gentlemen, remember now we set our factors equal to 0 and we solve. So we have x plus 5 is equal to 0, or 3x minus 1 is equal to 0. Here we subtract 5 from both sides to get x equals negative 5. Over here we'd add 1, which gives us 3x is equal to 1. And then we divide by 3, which would leave us with x also equaling 1/3. The next two examples I put in here, not for us to work through, but to be aware of that when you see any type of a polynomial function, the function of x is what makes the output 0. So the function of x, or f of x, is going to be equal to 0. So this is simply another form that you should be aware of, and when you see it, in order for us to work it, you're simply going to put 0 in for f of x and then solve it by factoring, or other methods that we'll learn throughout this unit. Okay? And the last things that I have for you here are just some special situations that you may run across. So for this first one, we're going to have to simply subtract 864 from both sides, which leaves us with 6x squared minus 864 is equal to 0. So in this one now, ladies and gentlemen, this brings across another unique situation where we are going to have to factor out the greatest common factor. In this case, if we do that, that would leave us with 6 times x squared minus 144. That, ladies and gentlemen, is the difference of two squares, which, if you remember, would be x plus 12 times x minus 12, because 144 is 12 squared. So now we take that, ladies and gentlemen, and we set them all equal to 0. Well, we know 6 doesn't equal to 0, so we can cross that one off. Then we have x plus 12 is equal to 0, or x minus 12 is equal to 0. So we would get x is equal to negative 12 or positive 12. The last example that we have here is grouping. If we group the first two, that would be x squared times x minus 11. And the second one would be negative 9 times x minus 11. So that would leave us with x minus 11 times x squared minus 9 is equal to 0. X squared minus 9 would give us x minus 11 times x plus 3 times x minus 3 is equal to 0. So our answers here would be x equals 11, or 3, or negative 3. Just another unique, fun situation for you to be aware of. All right, ladies and gentlemen, I know that's a little bit of information to throw at you all at once like that, but I'm sure you can all do it and do it very well. Again, if you have any questions, please make sure you come to class and ask them. And if there's anything else I can do to help, please make sure you email. As always, be safe and be healthy, and Lord's blessings on your day.